Hi there. What I'd like to do is go over limiting reactants. So we've got a few objectives that we're going to go over with this presentation. We're going to identify the limiting reactant in a chemical equation, identify what's in excess, and then calculate how much a mass is left over of one of our particular products that we're asked to find. So I'd like to start that off by sharing a short little demonstration video here. So what I have is this clear solution on the left is vinegar. So I've got 30 grams of vinegar in the Erlenmeyer flask. On the right I've got 10 grams of baking soda. And what I'm going to do is I'm going to mix these two chemicals together. So I've got the solution of vinegar and baking soda and 10 grams of that. And I have to add the vinegar real slow. If I don't add it slowly enough, then it will expand beyond the Erlenmeyer flask that it's being added to, and I don't want to do that because then I'm going to lose more of my product, so that will potentially cause some issues with my calculations. So I see some evidence of a chemical reaction taking place. There's lots of bubbles and foams that are bubbling up. What's happening is the carbon dioxide is being released from the solution. Now, instead of waiting for the solution to kind of settle down, what I've done is previously did this reaction, and there's a clear solution here. This is mostly water now because I've taken the time and swirled the vinegar and caused it to react with more of the baking soda. But we can see that there's still baking soda that's left over in this Erlenmeyer flask. Because the baking soda is left over, I'm going to say that the baking soda is in excess, and the vinegar then was my limiting reactant. Alright, so what I want to do is go through a sample problem. This reaction is a little bit different than the one that was shown in the demonstration, but basically we've got the same principles that are taking place. So if I've got a reaction that's given here, and I've got 40 grams of sodium hydroxide that's reacting with 60 grams of sulfuric acid, I want to know how much mass of the sodium sulfate I have left over. I'm not really concerned about how much water is left, but I want to know about this salt that is remaining. How much of this is left over? So what I have to do first is balance my equation. So I have to add a 2 coefficient in front of sodium hydroxide. I've got a 1 for sulfuric acid and a 1 for sodium sulfate, and a 2 for water. So I'm all balanced out. So what I have to do is go through some different conversions. So I have to figure out which one of these is my limiting reactant to figure out how much of this product I'm going to end up with. So the easiest way that I have found is to convert both of these gram values to moles. So that's the first thing I'm doing here. So this first reaction is the sodium hydroxide. So I'm taking my 40 grams of sodium hydroxide, dividing it by the molar mass, so that's where this 40.0 grams came from. So 40 divided by 40 ends up giving me 1 mole of sodium hydroxide, so I could write that here just to keep track if I needed to. I'm going to do the same thing with sulfuric acid. So I've got 60 grams of sulfuric acid, dividing by 98.09 grams, and this is again the molar mass of sulfuric acid. And I can find this from the periodic table. It's the mass of 2 hydrogens, the mass of 1 sulfur, and the mass of 4 oxygens added together. 6 gives me 0.612 moles of sulfuric acid. At this point, there's a couple different ways that I can compare these two numbers. What I have found to be easiest for me is to convert moles of one substance to moles of the other. So what I'm going to do is take this 1 mole of sodium hydroxide, because it's an easy number, 1. And I'm going to apply the mole ratio that's from the balanced equation up above. So I had 2 moles of sodium hydroxide to 1 mole of sulfuric acid. And I'm going to convert my 1 mole of sodium hydroxide to moles of sulfuric acid. So the relationship, molar relationship, is 1 mole of sulfuric acid to 2 moles of sodium hydroxide. So 1 divided by 2 gives me 0.500 moles of the sulfuric acid. So if I compare this 0.5 to this 0.6, well, 0.5 is a smaller value, so my limiting reactant is going to be however I got to this 0.5. So my limiting reactant is the sodium hydroxide. So I have that identified now because this is a smaller number than this, so it's going to run out faster. So since sodium hydroxide is my limiting reactant, I can now figure out how much of the sodium sulfate remains after the reaction takes place. So I'm going to take one step back. I'm going to go 1 mole sodium hydroxide, apply my molar ratio again, and it happens to be the same molar ratio, but this is from the balanced equation. So 1 times 1 mole of sodium sulfate divided by 2 moles of sodium hydroxide, and then I'm going to multiply by the molar mass of the sodium sulfate compound. And again, I'm adding the mass of 2 sodium plus 1 sulfur plus 4 oxygens, gives me 142.04 grams. So multiplying, or taking the product of the top, dividing by the product of the bottom, what I should end up with then, so this would be the theoretical value, 71.0 grams of sodium sulfate. What we could do from here is actually do the reaction and figure out what the actual amount would be from this theoretical amount. So this would be my expected amount. So an extension from this then would be to perform the reaction and figure out, well, what's my percent yield comparing my calculated output with an experimental output. So thanks for listening.